Hello students, let us look into an AC problem of maximum power transfer theorem. So this is the circuit and we need to find impedance ZL so that maximum power can be transferred to it in the network of the figure. So we are assuming that ZL has both an real component RL and there is a reactance part, imaginary reactance part XL. Okay, so the steps are step 1, we need to find VTH and ZTH. Okay, so the first thing is find VTH and ZTH, so out of which I will first talk about VTH. Now VTH, we know that we have to redraw the circuit. So this is the diagram. Now there are many ways in which we can do this. One of the most easiest ways that find out what is the current coming out from here, do current division and find out how much is dividing and going in this branch, because that current will not flow through here, it will not flow through this branch, okay, whereas it will flow through only this branch. So if you know the current, you multiply it with this impedance minus J3 ohms, you will get what is VTH. That is one of the most easiest method. But since most of you are mostly into mesh analysis, I will do this problem solving using mesh analysis. But as I said previously, you can do it very easily with the help of current division. You can use that method. Even if I am doing this problem, if you wish to do the problem using any other technique, you can do that. Okay, KVL technique, KCL technique, any technique you wish to use, you can use that. Okay, so this is the mesh analysis. So using mesh analysis, I will try to do it. So here for mesh 1, so KVL at mesh 1, KVL at mesh 1, so it will become plus minus. So this becomes 5 minus 3I1 minus J3 I1 minus I2 is equal to 0, from which I can get 3 plus J3 I1. You might be thinking, where is the minus gone? I have taken the minus the other side. Okay, let me write it like this then for the time being. Minus 3 plus J3. Okay, I have put minus outside the bracket. Plus J3 I2 is equal to minus 5. Okay, let this be my equation 1. Similarly, now I have to write for KVL at mesh 2. KVL at mesh 2, I will get, so let me draw the polarity. So this is going to be plus minus, and this is going to be, okay, so back of the element, so J3 I2 minus I1 plus 3 I2 plus of minus J3 I2, that is equal to 0. Okay, so from this I can take out I1 separately, so this is going to be minus J3 I1 plus, what about I2 component? So we are having J3 I2 and minus J3 I2, which will cancel out, so I will get 3 I2. Okay, I'll get 3 I2. J3 I2 and minus J3 I2 will cancel off. Okay, so now that is equal to 0. This is going to be my second equation. For solving this, I will have to use the matrix method. You all know the matrix method, which is minus 3 minus j3. Now I have taken it inside the bracket. Okay, that's why. Then j3, this is going to be minus j3, and this is 3, and here I am having I1 I2, which will give me minus 5 and 0, from which I can first calculate delta, because delta is important to be calculated. So delta is basically the matrix minus of 3 minus j3, j3 minus j3 and 3. So we know it's cross multiplication, this into this minus of this into this. I will get the answer as minus 18 minus 9j. This is what I will get. Okay, so next I will have to, for finding I2, I need to find only I2. There is no need for me to go for I1. So I2 is delta 2 divided by delta, where delta 2 is where I replace the second column. So minus 3 minus j3 and minus j3 is going to be there. Here it is going to be minus 5 and 0. That divided by delta, delta is already, I found out it as minus 18 minus 9j. Okay, now here cross multiplying this into this is going to give me 0 minus of minus 5. So minus of minus 5 into minus j3 divided by minus of 18 plus 9j. The minus and minus can cancel off, and here I will get minus and minus will become plus. So 5 3 is a 15j divided by 18 plus 9j. Okay, the answer of which will be 0.75, an angle of 63.43 degrees. So this is our I2, and we know that VTH is basically I2 into minus of J3. So from figure VTH is equal to minus J3 into I2, which comes out to be, so I have to multiply this 0.75 angle 63.43 with minus of 3i or minus of J3. Now I will get the answer as 2 as the real part and minus j, which I can even write it in in polar form as 2.24 with an angle of minus 26.57 degrees. Okay, so this is what is basically the VTH that we have found. So that I will have to keep it like this. So I have found out VTH. Next is finding ZTH. For finding ZTH, again I have to use the diagram. I have to put the diagram. So let me put it. Yes. Okay. So for finding ZTH, first thing that I have to do is I have to take out the voltage source, and instead of that I have to keep it as a short circuit. So here is my short circuit, and I have to find out what is the ZTH between these two. Okay, I have to find out what is ZTH here. So I will write the heading as ZTH. Okay, so for finding ZTH, the thing that we do is, you can see here again, those who are not familiar with series, parallel and all, have a look here. 3 is having one element here, another element here, which is connected to this element and this element. So 3 and this 3j or j3 are parallel. These two are parallel. Okay, now that parallel combination I can write it as a single one that will be in series with 3. Okay, that will be in series with 3. So that total will be again in parallel with this one. Okay, so in that sense, what I can write here is that ZTH is going to be equal to 3, oh sorry, okay, ZTH is going to be equal to 3 parallel with J3, the answer of that, plus 3, the answer of that should be parallel with minus J3. Okay, and this we can easily find out using a calculator. How do we do that? First 3 and 3, so I will write 3 inverse plus J3 inverse, the whole inverse, plus 3, the whole inverse, plus minus J3 inverse, the whole inverse. So when you are doing in a calculator, remember you have to put 3 brackets in the front and you have to just type it like this. If I type it like this, I will get the answer as, the answer is 1.8 minus J 2.4 ohms, or it can also be written as in polar form 3 angle minus 53.12 degrees. So this is ZTH. Therefore, step 2 is for maximum power transfer, isn't it? That is what we require. For maximum power transfer, what should be the value of ZL? Now let us look at what we have found out. See, if the second condition was when you are having this case, when ZL is equal to having both RL and XL. When both RL and XL has to be there, what should be the condition? The condition should be that ZL should be the conjugate of ZS. Okay, so let us first draw the circuit. The circuit is now like this, that we are having a VTH, which is given by plus minus this thing. This is going to be Vs. Vs is going to be equal to Vth, and then we are going to have a resistance, and that resistance is Zs. Zs is same as Zth. Okay, and then we are having ZL, and according to our, what do you say, just now derivation that we had seen, ZL should be equal to the conjugate of Zs. Therefore, Zs is equal to conjugate of Zth, sorry. Zs is equal to Zth, which is 1.8 minus J 2.4 ohms, and ZL will be equal to Zs conjugate, which comes out to be 1.8 plus J 2.4 ohms. Okay, now what is going to be the current? Okay, why I am saying this? Because we have to find out what is the maximum power, isn't it? That yesterday I should have done here, but I have not done. So right now I am going to do it. See, we are having ZS, and here we are having ZL. Okay, and then we are having the voltage, which is Vs, which in our case is Vth. Okay, and this is basically Zth. Now for the three conditions, for the three conditions, out of which the second one right now we are dealing with. And what was power? If you remember, we had also found out the equation for power. So here The power equation is basically the current square into RL. The current square into RL. And what is the current? The current is going to be whatever is the current we see here. So let me go back to this. Yeah. So this is going to be IL. And what is going to be IL? IL is going to be VTH divided by ZTH plus ZL. And what is ZL? ZL in our case is ZS conjugate, or basically ZTH conjugate. So I will write this as Z. I will write this as ZTH conjugate. So what will happen when you add two things which are conjugate to each other? The real part will remain, the imaginary part will cancel off. Okay, so let me write that in our case. Anyway, this is going to be IL, and our power is going to be IL square into RL, where what is RL? RL is the resistive part of ZL. RL is the resistive part or the real part of ZL. Okay, so that same thing I will write here. So I will write IL is going to be VTH. What is VTH? VTH we just now we had found out here that it is 2 minus j. Okay, let me write it as 2 minus j. I'm not writing the polar form. Okay, divided by ZTH and ZTH conjugate. Correct? So that is going to be 1.8 minus j 2.4, and its conjugate, is going to be plus 1.8 plus j 2.4, isn't it? Why? Because ZTH and ZL are basically conjugate in our case. Okay, so that I have to take the magnitude. So I have to take the magnitude of that. See what will happen here, the j 2.4 and minus j 2.4 will cancel off, and what we'll have is only 1.8 and 1.8 left here. Clear? Now again it's IL square, so I have to write one more thing here. It is magnitude of IL square, so I have to find out only what is the magnitude of this. I don't have to find anything else, I have to only find the magnitude square. So this is going to be 2 minus j divided by 1.8 plus 1.8 is 3.6, and therefore the power will be the magnitude of IL square into RL. Okay, now have a look here. Magnitude of IL. What I have to do is I have to take the polar form of that and just write the magnitude. So what is the polar form of, let me do it here separately. What is the polar form of 2 minus j divided by 3.6? The polar form of that is given by, you have to take your calculator and do 2 minus I divided by 3.6. You will get the answer as, the polar form, you will get the answer as 0.62 with an angle of minus 26.56. Okay, minus 26.56 degrees. That is what you will get, out of which we take only the magnitude part. So here I will get 0.62 the whole square. So I have taken the magnitude multiplied with RL. Now what is RL? RL is the real portion of ZL. What is the real portion of ZL? It is 1.8. So into 1.8. And the answer of this will be 0.69. 0.69 watts. So actually this should have been the third step. This is ZTH you have found out. This part, finding the power, should have been step 3. Sorry, I have crammed up in the last because I wanted to finish the whole problem within one page. Anyway, so this is what we have to do. So finding the impedance of ZL so that maximum power can be transferred to it. Find the maximum power. So the maximum power that we have found out is 0.69 watts. Okay, thank you.